Hello dear students, today I will discuss about maxima and minima. Maxima and minima is a well-known topic for you because this topic is related to just a function of one variable for maxima minima discussing. In the fourth unit also we will study about maxima and minima for function of two variables. Okay, so here the just formula is simple. First derivative test is also there, and second derivative this test. For finding second derivative, you can identify either maximum or minimum for the function. Okay. Just similar as you have already studied in 12th class, maxima minima. So here we will discuss about maxima and minima. Maxima and minima. Maxima and minima. Okay. So maximum value and minimum value of a function of single variable. How can we identify? Just graphically we can see. We know about increasing function and decreasing function. The condition for increasing and decreasing related to derivatives also we know. Suppose function fx, okay, or function is fx, that is denoted by y equal to fx. Generally we denote like this. Fx is the function. Here what is the maximum, minimum? That is depend on the given condition, given information in the questions. Just we have to write the expression for some, for just like volume, area, for maximum of volume, maximum of area. Just we write an expression for that area or volume, just like that. That will be the function. Maybe there maybe two variables are related, but by some condition we can write the value of one variable in terms of other variable, and then we can get a single variable function. Suppose this is function, and graph of this function, just we know. How can we understand what is maximum and minimum? For maximum and minimum, what will be the condition? Just you know, first derivative should be 0 and second derivative is negative, then maximum and second derivative is positive, then minimum at that point. So just understand that concept. Okay, so draw a graph of function, graph of a function. Suppose this is a graph of a function y equals to fx, graph of this function. Okay, so reference point means what? This is x-axis, this is x-axis, and this is y-axis. Just we require for identifying y-axis. This is origin, x-axis, this is y-axis. Negative side, and this. Now, graph of the function is maybe like this. Okay, so here just we can see that in a locality of a point. Locality of a point means x in this direction. Okay. So this is the graph of the function. That means at each point, if this function is continuous, that at each point we can get tangent. And similarly, we can get okay. Now, suppose in this place here just increasing function means just see start the value of x start from here x increase in this direction. So suppose this is the point corresponding to x equals to a. Corresponding to x equal to a, the value of function is this. Okay. Now, just as x increase in this direction, the value of x is a here, and the lower value is in the left hand side, upper value is in the right hand side. Just for a lower value of x than a, lower value, we see that if we draw here tangent, here tangent, just like this, tangent, here tangent, here tangent, here tangent, here tangent, here tangent, 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 and just draw the tangent, 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 just draw tangent, tangent, draw tangent, tangent, tangent. These are the tangents at this point. Tangent having slope. If this tangent make acute angle, fine, acute angle, because tangent like this making the angle acute angle, and acute angle, then its slope tan phi will be greater than 0. Slope tan phi greater than 0, that means derivative is greater than 0. And here is tangent, this tangent makes angle what? Psi. Tan psi is negative. That is what? Dy by dx is negative. For those points greater than a. Okay, up to this. Also for this tangent, also for this tangent, also for this tangent. So here we see that the points slightly less than a, for that point derivative is greater than 0. That is positive. And slightly greater than point here, tangents make obtuse angle. and derivative is less than 0 for slightly greater than 0. Just at this point, tangent is parallel to the x-axis. At this point, derivative is equals to 0 at x equals to a, and less than point a, x is less than a, this, x is equals to this, and x is greater than a, this. So just we see that here is the maximum point in this duration, in this neighborhood. For a neighborhood of x equal to a, in this place, just this is peak point, and here we can say the local maximum or maximum point. This is the point of maximum, and this is at this point function attains maximum value, because this value, this value, this value, this value, this all this value up to this value, all are small than this. This is maximum value for this for the neighborhood of a. Okay, here derivative changes sign. In this direction, change sign positive. In this direction, sign negative. Or here 0. So here function is stable, and first derivative changes sign at this point. Changes sign when we go through the point A. X passes through the point A. X increases from this to this in this direction. So when x passes through the point A, derivative just change sign from positive to negative. And at the point A, this function is stable. So here we see that derivative, just we can write if derivative changes sign from positive to negative as x passes through x equals to a, then at x equals to a, y, that is fx, attains maximum value. And if here we can see that this is negative, and just after this point, just direction of tangent is like this, like this, like this. So tangent make again acute angle. So positive. So negative to positive at minimum point. This is maximum point. This is minimum point at this point. Okay. So P, suppose P, this is suppose Q, this point. So negative to positive. So if dy by dx changes sign from negative to positive as x passes through x equals to a. Then at x equals to a, function y equals to fx attains minimum value. Okay. Negative to positive, first derivative test. This is first derivative test. First derivative test. First derivative test. First derivative test for function to be maximum or minimum. First derivative of the function changes sign from positive to negative whenever we passes through the point x equal to a. Then at the point a, positive to negative, at the point a, function will attains maximum value. If negative to positive, then function will attains minimum value. And point A is called maximum or minimum point. Okay? And just here we see that at the point x equal to a, derivative is 0. At the point a, at x equals to a, derivative is equals to 0. Okay? So this is first derivative test. And here for second derivative test, how can we decide? By using second derivative. So see here, and in the case of second derivative, just here, suppose its neighborhood is this, is a local maximum minima neighborhood. This distance is what? H. So a minus h. This is a, this is h. So a minus h and a plus h. Some value is subtracted from a. This is the value what? A minus h. This is h. H. Okay. So this distance is h. And also this distance is h. So interval this we can make. Here h distance, 2h distance. This is the interval. Our in between point is a. So we can make two intervals. So this to this and this to this. So a minus h to a and a to a plus h. This interval and this interval. In this interval, here, just in this direction, here, derivative greater than 0, that is increasing function. Derivative always, because here we see that the function is increased. We know the for increasing function derivative is greater than 0 and for decreasing function derivative is less than 0. So, in this derivative is greater than 0. At the point a, derivative is 0. In this interval, derivative less than 0. So, in this interval, derivative, that is a function of x also. This is a function of x also. This is dy by dx, itself a function. Itself a function. And this, its derivative in this interval decrease because it changes sign from positive to negative. So in this small interval we see that the function, what function? Derivative itself a function of x. Y fx is a function of x and dy by dx is also a function of x. So this function is decreasing in this interval, and decreasing means function is decreasing means its derivative is less than 0. So its derivative, that is f dash x, that is d2y by dx square is negative. Okay, for maximum value. For maximum, because here just sign changes at this point, positive to negative. Negative means derivative changes sign. So derivative as a function of x, decreasing, function is decreasing. So its derivative means derivative of derivative is less than 0 for maximum point. Here this is the minimum point. Here derivative sign changes negative to positive. That is derivative as a function. Derivative is increasing. Function, that is derivative, is increasing. That is differentiation of derivative is greater than 0, increasing. So this is for maximum and this is less than 0 for maximum. Similarly, for minimum, derivative is increasing. So derivative as a function. d2y by dx square is greater than 0. Derivative of the function is greater than 0 because derivative itself a function. So in this interval, in this point, at this point, in this interval, this will be the increasing function. So its derivative, that is derivative of derivative, is greater than 0 for minimum. Okay. So second derivative test, how can we see that second derivative test? The state second derivative test means here fs is second derivative test. Second derivative test fx is maximum or minimum for fx is maximum or minimum, derivative is equals to 0. That is dfx upon dx equals to 0. And solving it, for fx is maximum or minimum, derivative is 0 at x equals to a, then fx is maximum if its again derivative d2y by dx square is less than 0 at x equals to a. Then fx is maximum. For maximum or minimum, derivative is 0. Say at x equal to a. Then fx is for x equal to a, derivative is 0. And for deciding whether a is maximum or minimum, in this case, just second derivative you have to find, and for that point, second derivative you have to find. If second derivative less than 0 at x equal to a, then function is maximum. Okay, and fx is minimum if second derivative is greater than 0 at x equals to a. Okay. Means if derivative is 0 at point, say at point x equal to a, for fx is maximum or minima, derivative is equals to 0 at x equal to a. Then at a, whether it is maximum or minimum, for deciding that, just second derivative you have to find, and at this point, if second derivative less than 0, then maximum, greater than 0, then minimum. Okay? Just we have seen by discussion here. Okay, this is second derivative test. So this is the simple process. Also you know from previous class. So for maximum minima, just you have to differentiate it function equal to 0 and solve and find the value of x points. These points are called maximum point or minimum point. For deciding whether maximum or minimum, just you have to find second derivative, and if second derivative less than 0, then maximum, if greater than 0, then minimum. If second derivative is equal to 0, then neither maximum nor minimum. And if second derivative is 0, then try for first derivative test. First derivative test. Then try first derivative test. Okay. Then try first derivative test. For deciding maxima or minima at x equals to a. If second derivative is 0, then try first derivative test for deciding maxima or minima. Okay. And generally, if by using first derivative test we get that there is no changes in derivatives, first derivatives, while approaching the point A, then there is no maxima, no minima. So if d2y by dx square, then we can also test for first derivative test. Okay. This is simple formula for finding maximum or minimum value of a function and the points at which function is maximum or minimum. And there is also some point in the curve at which the function is neither maximum nor minimum, that is no changes of derivatives, just like this. Suppose we are having like this curve. Suppose this is x-axis, this is y-axis, and this is a curve and this is a point. And here we see that in this situation, we can see that at this point, derivative is equals to 0. At this point derivative equals to 0, but function is increasing here, also function is increasing. Suppose this is point at x equals to a, and at the point a, derivative dy by dx at a equals to 0. But here curve is increasing, also here increasing. So before this point curve is increasing, after this point also curve is increasing. That is, here derivative y dash is greater than 0, here also y dash is greater than 0. No changes. No changes. So this type of point is called point of inflection. Point of neither maxima nor minima. Neither maxima nor minima. Point of inflection. Okay. In this case, just derivative of derivative is also greater than, here derivative of derivative is equals to 0 here at this point. Okay, derivative no change, increasing. So just in this point, what at this point, just a condition for this point, first derivative 0, second derivative 0, and third derivative not 0. Third derivative not 0. This is for point of inflection. This is for point of inflection. Okay. For point of inflection, what is the condition? First derivative 0, second derivative 0, and third derivative is not 0. After getting second derivative 0, just try to first derivative test. If no decision is there, then just find third derivative. And third derivative is not equals to 0, that is neither maxima nor minima. So point of inflection means the point where derivative does not changes its sign. But in this place, derivative as a function its value is 0, and second derivative will also 0 at such type of points. So point of inflection for this condition, we can say that this type of point is called where first derivative, second derivative is 0, but third derivative is not equals to 0. So point of inflection is this type of points. Okay, whether a point of inflection or not, just find first derivative 0, second derivative, find the points, and then at that points find the derivative of second derivative, that is also 0, and find also third derivative, and at that point check, if not 0, then point of inflection. Okay. So now we can find the maximum value or minimum value of a function by using first derivative test also, changes of sign in a small interval containing the points, that is slightly less value, slightly greater value, and for second derivative test, just find the second derivative and find value of at that point, if negative then maximum, then positive then minimum. Okay, if second derivative is 0, then just try by using first derivative test. If not, we cannot decide, then just find third derivative. If third derivative is not equals to 0, then you can say the point is a point of inflection, that is there is no maxima, no minima. Okay. Now we will solve some questions. Just you also know about this topic, very well from previous class. So there is nothing for doing questions. So some questions I will solve now. Let's see. Take question first. Okay, that is simple questions. So that the sine x, sine x 1 plus cos x is a maximum when x equal to pi by 3. Sin x 1 plus cos x is a maximum at x equal to pi by 3. So we have to test here. Question first. Given function is fx equals to sin x 1 plus cos x. Just we have to show that at x equal to pi by 3, a point, at that point this trigonometric function is maximum. Okay, at pi by 3, just we have to show. Okay, sin x 1 plus cos x. We have to show that fx is maximum at x equals to pi by 3. Okay. So for maximum, this is the point, particular point, a equal to pi by 3. At this point, we have to show its maximum. So first of all, just find the stationary points. A stationary point means where function having first derivative 0. Okay. So extreme point, maximum. In the curve, the maximum point is there, corresponding to the value of x, for which the function is maximum. That point is called stationary points or extreme point. At that point, function having maximum value or minimum value. So here, first of all, find stationary points. So for, just we can write for maxima or minima. Just we can see that in the diagram, for maximum point or for minimum point, derivative should be 0. So here, for maximum or minimum, for maxima or minimum, for maxima or minima, f dash x equals to what? 0. Derivative. F dash x equal to 0. So f dash x, just find derivatives. Okay. F dash x equals to 0. Now, f dash x equals to, just find its derivative. Product of two function. So we can find derivative. So derivative sign is cos x 1 plus cos x. Just you have to find first derivative and then put 0 and then find the value of, and then again find second derivative and test by second derivative. Okay. So here cos x 1 plus cos x, and here just sin x, and in bracket what? Zero minus sin x. Okay. This is first derivative. So implies first derivative is equals to what? Just multiply cos x plus cos square x minus 1 minus sin 1 minus cos square x. We can write like this: cos square x minus sin square x 1 minus cos square x. So just we can solve it. Cos square minus minus plus cos square, 2 cos square x, 2 cos square x plus cos x minus 1. So this is first derivative. Okay, implies f dash x is 0. This implies, because derivative should be 0. So this implies this is equals to 2 cos square x plus cos x minus 1 equals to 0. Now we can solve it. Okay. So using what? 2 minus 1 minus 2. So 2 cos square x cos x minus 2 cos x minus 1 equals to 0. Just we can use the factorization here, cos square, second degree in cos square. So just for finding the value of x, factorize it. Minus 1 is here, plus is here. So just see, minus minus plus plus 1 cos x minus 2 cos square x. So minus 2 cos square x. Okay. Now here 2 cos x is common. Cos x is common. Then 2 cos x minus 1 plus 2 cos x minus 1 equals to 0. So here, from here you can get 2 cos x minus 1 into cos x plus 1 equals to 0. So implies, just here, cos x equals to half and cos x equals to minus 1. So implies x equals to half means 60 degree, pi by 3, and x equals to pi, cos pi minus 1. So we get 2 points, pi by 3 and pi. Now for deciding, these are the stationary points. For deciding whether in this, at this point first derivative is 0. At this point function is maximum. For that, just we have to find second derivative. Okay. So here find second derivative. Now f dash x double dash x, second derivative. First is f dash x equals to this. F dash x equal to this. Okay. So here this is also, this can be written also like this, first derivative, and first getting second derivative, just we can solve it also. This from here we can write, because f dash x equal to this is factorized like this. So we have f dash x is equals to, also this can be written. Okay. So 2 cos x minus 1 into cos x plus 1. This can be written f dash x equals to. Now from here just differentiate 2 times. Okay. So differentiate, product of 2 function, differentiate first this. So minus 2 sin x minus 0, first time differentiate, and cos x plus 1, and plus differentiation of this, minus sin x plus 0 into 2 cos x minus 1. So just solve it. Minus 2 sin x into cos x minus 2 sin x. Minus 2 sin x into cos x minus 2 sin x minus into minus 2 cos x sin x. minus 2 sin x cos x plus sin x. Just we see that here sin x is common from all. Okay. So sin x minus sin x is common from all, and then we can write minus common. So 2 cos x 4x 4 cos x minus sin x common, so 2 cos x 4x, and here minus sin x is common, means 2 minus 1 plus 1. This is second derivative. Okay, f dash double dash x. Okay, second derivative is this, just like minus sin x 4 cos x plus 1. Now for testing whether at this point function is maximum or not, just we can use second derivative test. We see that f double dash pi by 3 at the point x equal to pi by 3, we see that for x equals to pi by 3 f double dash minus sine pi by 3 4 into cos pi by 3 plus 1. Just we can solve it. Okay, what cos sin 60 means root 3 by 2 4 cos pi by 3 cos 60 into 1 by 2 plus 1 is equals to what? Minus 3 by 2. This is positive or negative. Just here you can write direct. Because this is negative, sin pi by 3, sin 60, root 3 by 2. So minus root 3 by 2, 4 into cos 60, 1 by 2, plus this, just 2, 2, 3, 3 root 3 by 2. So this is equals to what? Minus 3 root 3 by 2. Negative value is this. Okay. Four cos pi by 3 cos 60 is this, negative. Thus which implies that fx is maximum at x equals to pi by 3. X equal to pi by 3. And for testing at pi, just our record result is obtained now. Now, also for x equals to pi, we get f double dash pi is equals to 0. Because if you have here pi, then sin pi 0. So total 0. Double derivative is 0. Then just we can try for first derivative test. So here first derivative, what is first derivative? First derivative is this. Now the point is what? Pi. So just slightly less value of pi, slightly greater value of pi. Just we can see that for slightly less value of pi, this slightly less value of pi means what? This is pi. Slightly less value of pi means here cos is negative. So cos is negative, slightly less value. This is pi angle. Here slightly less value in this function. Cos is negative. So for slightly less value is here cos negative. So minus 2 minus of sign and here minus sign. So total is minus sign. Okay. Here negative sign, but cos x is greater than minus 1 and less than plus 1. So this will be positive. So this is negative. So totally negative. So negative. And so slightly greater than pi here. Here pi cos x is also negative. So this is also negative. So there is no changes. We see. We see that f dash x does not changes its sign when x passes through x equals to a. We see that f dash x does not changes its sign when x passes through x equal to a. Therefore, a means not a pi. Therefore, fx has neither maxima nor minima at x equals to pi. Therefore, fx has neither maxima, has neither maxima or nor minima at x equals to pi. Does not changes. Just you can write that for slightly less value of pi, derivative f dash x is negative, and also for slightly greater than value of pi, f dash is also negative. So f dash x does not changes its sign when x passes through x equal to pi. Therefore, fx has neither maximum nor minima at x equal to pi, and at x equal to pi by 3, fx is maximum. Okay. So here we can you can write also like this. Before this, you can also write we observe that for slightly less value of pi or slightly less value of pi, f dash x is negative, and also for slightly greater value of pi, f dash is also negative. So we see that so or thus you can write like this. We observe that for slightly less value of pi, f dash x is negative, and also for slightly greater value of pi, f dash x is also negative. Thus, we see that f dash x does not changes its sign when x passes through pi. Therefore, fx is neither minimum, maximum nor minimum value at x equals to pi. Okay. Is fx is neither maximum or nor minimum at x equal to pi. So this is the process for deciding whether for a point function is maximum or minimum. Okay. When second derivative is 0, then just you can try for first derivative test. If sign will change, then you can decide whether maximum or minimum. But if sign is not changes, then neither maximum nor minimum at x equal to pi. Okay, now take another question. The maximum minimum for the practical problem, that is just given information can be written as a function of single variable, and you can apply for finding maximum minimum value of that particular type of function. So here just take another question, that is a window has the form of a rectangle surmounted by a semicircle. If the perimeter is 40 feet, find its dimension so that greatest amount of light may be admitted. So this type of problem, that is practical problems, just information is given, some information is given in the question, in this question, just we have to establish a function may contain two types of variable quantity, but by using some condition, just write the one value of one variable in another variable, terms of another variable, then we can get a single variable function, and you can apply this maximum minima rule for finding the maximum. So here, what is dimension? So that window having rectangle surmounted by a semicircle, perimeter is given 40 feet, find its dimension, just we have to find its dimension. Okay, so dimension means what? Length, breadth of rectangle and radius of circle, semicircle. Okay, so length and breadth we have to find here, and radius. Just greatest amount of light may be admitted. That is, greatest amount of light may be admitted means area should be greatest, because from window light will come, so greatest amount of light, that is area should be greatest. Okay, so area may be maximum for that dimension. So here just question second, just I will write function and solve this. You have to write in details for exam purpose. Okay, so here rectangle, so suppose This is rectangle. Shape of window, this is rectangle. Clear? And rectangle is surmounted by a semicircle. So we can draw like this. Okay. So a rectangle surmounted by semicircle. So just we have to find its perimeter is given. Perimeter means this length is given. Now we have to find the dimension of this window so that maximum light can be admitted. That is, maximum light may come to the room through this window. That is, area should be maximum. So we will require finding the maximum value, for which dimension. That is, we have to find the dimension, that is for which value of, here we will set down variable quantity. So here say this is x. Suppose radius of semicircle is x. If this is x, then this is also x. And this is rectangle, so this is 2x. This is 2x. Because x plus x, 2x. 2x length of the rectangle. And y is, suppose, height of the rectangle. Now, we can write its perimeter. Okay. So here given the perimeter of window is equals to 40 feet. 40 feet perimeter of window. Window is this. Consider on this window. Okay. Now, perimeter. This is 2x. This is side also y. This is also y. Y plus y, 2y. This is 2x. So 2x plus 2y and semicircular arc 2 pi r by 2, that is pi r. R means radius, pi x. So pi x semicircular arc plus 2x plus 2y equals to 40. So this is given perimeter 40. So now this. From here we can write 2y equals to 40 minus pi x minus 2x, y equals to 20, just divide by 2, 20 minus pi x by 2 minus x, just divide by 2. So this is the value of y. Okay. So this is our condition. From here, for dimension, there are two things, x and y. So just we have to find now what? First function, area function. So area of window For light, maximum light, area of window should be maximum. So area of window is equals to what? Area of this window. Area of this rectangle and area of this semicircle. Area of this semicircle, circular area is pi r square. So semicircular area is pi r square by 2. R means what? X. So here we can write semicircular first pi r square by 2, that is x square by 2, plus 2x into y. 2x into y. Clear? So suppose area is denoted by A. Suppose area is denoted by A, then area equals to pi x square by 2. Just convert y in terms of x. So we write like this. In place of y, this 2x 20 minus pi x by 2 minus x. So this is equals to, now we can write like this, 2x pi square by 2 plus 40x, just multiply it, 2 into 20 40x minus 2 to cancel, pi x square minus 2x square. Okay, so here we can write it just like pi x square by 2. So pi x square here, pi x square. So we see that pi x square by 2 and pi x square, that is minus pi x square by 2. Okay, so 40x minus pi x square by 2 minus 2x square. So we can write like this, 40x minus pi minus 4 x square by 2. Okay, so 2 4 x square, so x square common, pi minus 4, like this, a plus sign is there. This is A. So this is our function. Just for this type of questions, you have to find first our required function or required objectives, means required things. What should be maximum or minimum? That is area. Here area. So area function is this in terms of x. Now area should be for greatest amount of light should be admitted. Greatest amount of light may be admitted the area of window should be maximum. Therefore, for maximum, dA by dx is equals to 0. Therefore, for maxima, dA by dx equals to 0. Now, dA by dx equals to 0. Our function is what? Pi plus pi. This is function. Okay. For maxima, dA by dx equals to 0. Now dA by dx, A is this. Just differentiate it. Differentiate it. 40x, 40 minus pi plus for constant, x square by 2, x square 2x. So pi plus 4 into 2x by 2. Okay, and here the y equals to this, just write y equals to 20 minus pi x by 2 minus x. Now this is equals to what? 40 minus pi plus 4 into x. This is dA by dx. And dA by dx equal to 0. dA by dx equals to 0. Okay. So A equals to this also. Note down A equals to what? A equals to 40x minus pi plus 4 x square by 2. Therefore, dA by dx equals to 0 for maximum value. This implies this is equals to 0. 40 minus pi by 4, 40 minus pi plus 4 x equals to 0. Now solving it, we get x equals to 40 by pi plus 4. 40 by pi plus 4. X equals to 40 by pi plus 4. So x equals to 40 by pi plus 4. Also, y equals to this, because these are the dimension, na? So radius 2x, rectangle dimension. So rectangle dimension can be found. Just we require the dimension. For which dimension? Maximum right come. So here y equals to 20 minus pi by 2 plus 1 into x, just minus common, and x also common, so pi by 2 plus 1. So this is the value. And here put x equals to 40 by 20 minus pi plus 2 by 2, solve it, 40 upon pi plus 4, like this. Okay, now it can be solved, and after solving this we get taking LCM, just we can write 2, just write this pi plus 4, 20 pi plus 2 minus here 20, implies y equals to what? 20 pi plus 4 minus 20 pi plus 2 upon pi plus 4. So this is equals to, just we can solve 20 pi plus 80, 20 pi plus 80 minus 20 pi minus 40 upon pi plus 4. So just see 20 pi cancel, 80 minus 40, 40 by pi plus 4. Y equals to the same value. The x equals to 40 by pi plus 4, y equals to also 40 by pi plus 4. Okay, so we can see that this, and also x equals to what? 40 by pi plus 4. X and y implies x equals to y. So we can see that what? That the area of the window is maximum when the radius, just you see here, radius x and y are equal, that is height of the rectangle. Okay, just we can say that thus the area of window is maximum when the radius of semi circle is equal to the height of rectangle. That is, dimensions are x equal to y equals to 40 upon pi plus 4. 40 upon pi plus 4. So this is dimension. Okay, so this type of questions also can be solved. Can be found by maximum or minimum value of a particular thing which have to maximize or minimize. Okay. So similar type of questions, just here what is requirement, that first of all we have to establish our function. Okay. Which will be maximum or minimum according as given in the question. Now take another question here. This question is that a rectangular sheet of metal, so very important questions, note down it. Okay. A rectangular sheet of metal of length 6 meter and width 2 meter is given. 4 equal squares are removed from the corners. The side of this sheet are now turned up to form an open rectangular box. Find approximately the height of the box such that the volume of the box is maximum. So very important question and simple question. Okay. So here what is given? It is given that a rectangular sheet of 6 meter length and height, width 2 meter. That is like this. Just in this question also we have to write what is volume of the box. Just volume will be our function. Volume of the box is maximum. That is, volume should be maximum. So we have to establish the relation volume in terms of some unknown quantity. Okay. So here just what given? Rectangular sheet. So rectangular sheet means, suppose we are having rectangular sheet like this. Its length 6 meters and its width 2 meters. Clear? And 4 squares, equal squares, are removed from 4 corners. So suppose we are removing this part. Same part, just you have to draw like same. That we have to remove this part from here. Okay. Four corner part. So equal squares. So just suppose this is x length, this is x length, squares. This is square. So this length is what? X. Suppose this x length. This is length x. This length is x. Okay. We have to remove this and just fold up for making a box. So height of the box will be what? X. Height. Clear? So we have to find what? Height of the box. So that the volume of the box is maximum. So the rectangular sheet is this. So we get cuboid. So volume, how can we write the volume of cuboid? Length into breadth into height. So here, just we see that this is 6 centimeter, 6 centimeter, total is 6. So now when we fold up it for making box, then the length of the box will be what? From here, 6 minus 2x. 6 minus 2x. Because from here, this is x, this is x. 2x minus from 6. Now, here, just like from this plus 2, 2 minus 2x. This plus. Okay. So, this is, will be the what? Length, breadth and height is x. So this is length, breadth and height is x. So just we can draw this in this place also here. 6 minus 2x up to this. This is length, this is breadth and height is x. So we can write volume. Volume of box is what? Just multiply height x, length breadth. So x into 6 minus 2x, 2 minus 2x. This is volume. Let x be the length of side of a square. Then let x be the length of side of the squares. Then volume of box is V equals to this. So this is our volume. Now this volume should be maximum. And x is what? Then x is height of, then x is height of box. So volume of box is this. Now from this function, this is volume is a function of x. So for maximum volume, dv by dx equals to 0. Now dv by dx, just find dv by dx. So dv by dx, differentiate it. First function 1 into 6 minus 2x, 2 minus 2x plus x, differentiate it, minus 2, 2 minus 2x plus x into 6 minus 2x into minus 2. Differentiation of product of 3 function. So this just we can multiply it. We can see the value. Okay, its value can be collecting here. What? 6 into 2, 12 minus 4x minus 12x plus 4x square. Okay. Now here minus 4x, 2x minus 2x square, so minus 4x, and here minus 2x square, minus minus plus 8x square. Okay, so 2x minus 2x square, so 4, 2x minus 2x square. So 2 into 2, another 2 into 2, not 8, 2, 4. Okay, so minus 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 plus. So 4 this, and here minus 2. So minus 12x minus minus plus 4x square. Minus 2x minus minus plus 4x square. So it can be solved. 4, 4, 8x square, and here also 8, 12x square minus 4 minus 4 minus 12, 4, 4, 8, 8, 20, x. (32x plus 12). Okay, 12x square minus 32x plus 12. 12. Okay, so this is derivative, dv by dx. We can write also dv by dx for short writing. Okay, here 12, just 4 common, 3x square minus 8x plus 3. Okay, clear? Now for maximum volume, this should be 0. Therefore dv by dx is equals to 0 implies, this is equals to 0 implies. So 4, 3x square minus 8x plus 3 equals to 0. It can be solved. 3x square minus 8x plus 3 equals to 0. Now after solving, we can get the value just like this. This is first derivative. Okay. So here for solving this, use x equals to, by using quadratic formula, x square, x equals to minus b, that is 8, minus of minus 8, plus minus root b square, means minus 8 square, 4ac, 3 into 3 into 3 into 3 upon 2 into 3. Just we can write here, see, 8 plus minus root of 64 minus 36 upon 6. So this can be written what? 64 minus 36, 64 minus 36, 28. 28 means 4 into 7, 2 root 7. So here we can write 8 plus minus 2 root 7 by 6. So this is the value. Okay. What is the value? X equals to, just 2 can be cancelled out, 4 plus root 7 by 2, 4 minus root 7 by 2, and 4 plus root 7 by 2. 3, sorry, 3. 3. 2 can be cancelled out. So here 4 minus root 7 by 3 and 4 plus root 7 by 3. So 4 plus root 7 near about 7. So 4 to 6, 6 to 2, greater than 2. This is greater than 2 value, or this is less value. So here x equals to 4 plus root 7 by 3 is not possible. Okay, x, because this is greater than 2. This is greater than 2. Because since because 4 plus root 7 by 3 is greater than 2. So total length is 2, or this is greater than 2. It is impossible. So it is not possible because this is greater than 2. Therefore x equals to 4 minus root 7 by 3. So this is the x, that is height of the box. Okay. Now for this value, function should be maximum. Volume should be maximum. Just for testing, we have to find second derivative. Okay. So here see that this is first derivative. This is first derivative. Now we have second derivative, d2v by dx square. This is first derivative, the derivative of this. Okay, derivative of this. So we can write differentiation of this 4 in bracket 6x minus 8 like this. 6x minus 8. This is second derivative. And this is equals to 4 6 into 4 minus root 7 by 3 minus 8. For x equals to 4 minus root 7 by 3. Okay. Now we can solve it. 3, 2, 2 into 4, 8 minus 2 root 7 minus 8. So this is equals to 8, 8 cancel. So minus 8 root 7. This is negative. Second derivative negative. Minus 8 root 7. Okay. Minus 8 root 7. This. 6x minus 8. No? So second derivative is negative. That means volume is maximum. Thus we can write thus for maximum volume the height of box should be 4 minus root 7 by 3. Okay. This implies V is maximum. After this line, just write this. Thus, for maximum volume, the height of the box should be x equals to, or just write this, 4 minus root 7 by 3 meters. Okay. So this is the height. Approximately, this is the height of the, will be the height of the box for maximum volume of this box. Okay. So similarly, we can take another question. So this verbal problem is very, very important also. Okay. So try to solve some questions. First of all, you have to set up function which should be maximum or minimum. Okay. So next question is, just see here, find the altitude and the semi-vertical angle of a cone. Semi-vertical angle and altitude means height of the cone. Okay. Altitude and semi-vertical angle of a cone of least volume which can be circumscribed to a sphere of radius. Just we have to draw a cone which circumscribes a sphere of radius. And in this case, least volume. Cone of least volume. The volume of cone should be least. In that case, just we have to find the altitude of the cone and semi-vertical angle of the cone. Altitude means height of the cone. Okay. So here, for question 4, just we draw the diagram. Just we have to draw a cone which circumscribe, that is cone will be at the outer side and inner side sphere. So here suppose this is a sphere. Suppose this is a sphere. Okay. Now we have to draw a cone. Just suppose this is a sphere and This is A. Just we have to draw diagram A, B, C, and this is height. And this is okay. So this is our diagram for just we draw. We make a cone circumscribe this sphere, or this is radius of sphere. This is sphere. Okay, this is what? 3D sphere. This is sphere. This is diagram for sphere. Just this is sphere, and this is cone ABC, and this is D. Suppose this is D, this is E, this is O. So just we draw this cone circumscribe this sphere. Sphere having radius A. And semi-vertical angle, suppose what is semi-vertical angle? This angle is known as semi-vertical angle. Just we have to find this. Suppose semi-vertical angle is alpha and height from this to this. So suppose height is h. Okay, so let altitude and semi vertical angle of cone are h and alpha. Then just we have to make what? Least volume of the cone. Okay, so what is the volume? Then volume of the cone is V equals to 1 by 3 pi r square h. Just we know formula 1 by 3 pi r square h. R means radius. So radius is BD. 1 by 3 pi BD square. Height is h. So 1 by 3 BD square 1 by 3 pi r square h. Volume equals to 1 by 3 pi r square h. BD. So here BD can be found. BD, just this right angle triangle. Okay. So in triangle ABD, just tan alpha, this is perpendicular by base h. So BD by h implies BD equals to what? H tan alpha. So here we can write 1 by 3 pi h tan alpha square h. So this is equals to 1 by 3 pi h cube tan square alpha. So this is volume. By using this diagram, we find the BD. So BD 1 by 3 pi r square is for volume of the cone, h height, radius BD. This is the radius. So this is volume. Now here two things are given. Just what? H and alpha. So just we have to find h and alpha both. So convert one of them in terms of the other. That is just we find tan alpha. Because A is given radius. So just we can use also this triangle, right angle triangle. In this right angle triangle we can write value of tan alpha. Okay. Similarly, in this type. Here we can write in triangle AEO tan alpha equals to perpendicular this EO by base this EA. So this is EO means A. EO means A upon EA. Okay, and EA can be found. EA can be found by using Pythagoras theorem. So just see, this is A. So this value from here to here, h minus A. So here also in triangle AEO, AE square plus EO square equals to AO square. EA square equals to AO या OA square minus EO square. So OA square, OA square. This is A. Total is H. So H minus A. So this is H minus A square minus EO square. EO square A square. So this is equals to what? H square minus 2AH. A square cancel. So EA equals to is this. So this implies what? EA equals to root over H square minus 2AH. EA equals to. That this EA is used here now. A upon root over H square minus 2AH. So this tan alpha just put here. 1 by 3 pi h cube tan alpha, this A by root of h square minus 2AH square. So this is equals to what? 1 by 3. 1 by 3 here pi h cube A square upon h square minus 2AH. So 1h common and cancel out. So h square. So here we can write 1 by 3 pi A square h square upon h minus 2A. 1 by 3 pi a square, 1 by 3 pi a square, h 1h cancel to h square upon 1h minus 2a, 2a. So this is our function volume in terms of h. So b is the function of h. Now h is our variable. Now we have to find for least volume of the cone. So for least volume of the cone, for least value of volume of cone, we must have what? dV by dH is equals to 0. dV by ds equals to 0. So now this is volume. Okay, so here write volume. Volume is what? V equals to 1 by 3 pi a square h square upon h minus 2a. This is volume. Okay, this. Now it's dV by dx. We have to differentiate it. Okay. Now dV by dH, just differentiate it. 1 by 3 pi a square, 1 by 3 pi a square, just differentiate it. H upon h minus 2a, this is the variable h. So this is denominator. Just use the rule of derivative u by v form. Okay, so what will be? H minus 2a square denominator square, denominator h minus 2a into numerator, the derivative of numerator 2h minus h square, derivative of this 1. Okay, this is the differentiation of this. Now this is equals to 1 by 3 pi a square, just solve it. What? 2h square minus 2ah 4ah, 2 to 4 ah minus h square upon h minus 2a square. Okay, so here just we see that 1 by 3 pi a square, just what? H square minus h square minus 4ah upon h minus 2a whole square. This is our second derivative. Okay, sorry, first derivative. This is our first derivative, dV by dH. Now just for maximum, dV by dx is equals to 0. So implies what we have to find here? Value of h. Value of h. Okay, so derivative is equals to 0. This is equals to 0. This is equals to 0. 1 by 3 pi a square, just h square minus 4ah upon h minus 2a square equals to 0. So this gives what? This is not 0. This is multiplied by this. So h square minus 4ah equals to 0. So here h minus 4a equals to 0. So from here we get h equals to 0 or h equals to 4a. So 0 is not possible. Implies h equals to 4a. H equals to 0 is not possible. height is 0, not possible. So h equals to 4a. So we get h equals to 4a. Okay, h equals to 4a. This is the altitude, height of the cone. So our second thing is what? H equals to 4a. And now here h equals to 4a for maximum this. Whether for this 4a it is maximum or not, just you can find second derivative and can see. Or in other way, you can also see that first derivative is this. Okay. For slightly less value and greater value, you can see here what is second, because just now we have to decide whether for h equals to 4a b is maximum or minimum, because second derivative test either negative or you can use also first derivative test. Here you can do it second derivative, that is find second time differentiation by using division rule. That will be more mix of values of h, so we can use first derivative here. So see here first derivative is what? Just we see here first derivative, right? First derivative is this, na? So this is first derivative. We see that dv by dx is equals to 1 by 3 pi a square and h minus 4a, h minus 4a upon h minus 2a square. Just you can write like this. We say that first derivative is what? If our point is 4a, slightly less value of 4a, slightly less value, that is h is less than 4a, h is less than 4a, then we see that just for minimum list, so for testing here, just we see that first derivative test, derivative is negative for slightly less value of 4a. Derivative here h, first derivative is negative because just less value, h is just less 4a, so this value is just less than 4a, then less value, greater value, negative, this is always positive because it's square, so negative value, so this is negative for slightly less value of 4a, and is positive for slightly greater value of 4a. Just greater value of 4a, it is greater than positive, it is always positive, so positive. Which implies that dv by dx, dv by dx changes its sign from negative to positive. dv by dh changes its sign from negative to positive. So v is minimum, negative to positive, negative to positive. So minimum at h equals to 4a. Minimum, least. Okay, so altitude is find out. Now semi-vertical angle we can find by using this triangle. Also in triangle AEO, sin alpha equals to perpendicular by hypotenuse. Perpendicular what? Alpha. This is perpendicular by hypotenuse AO. So EO upon A. EO means A. AO means H minus A. That is A upon H equals to 4A minus A. A by 3. A by 3. So this is equals to what? 1 by 3. This is equals to 1 by 3. So implies sin alpha equals to 1 by 3. So alpha equals to sin inverse 1 by 3. So this is semi-vertical angle and this is height. So height of the cone is 4a, where a is given as a radius of sphere, and semi-vertical angle alpha is sin inverse 1 by 3. So this is the solution of this practical problem. Okay, this type of problem, there are many problems, just you have to solve after establishing the relation between given constants in the question. Okay, now I will give some questions for your practice. Just do all these questions. First of all, understand the questions and then just write required function which denotes the main objectives which should be maximum or minimum, and if that contains two unknown quantity, then just by using any of the condition given in the question, just write the value of one unknown in terms of another unknown in the given objects, and that objects will be the function of single variable. That will be our required function. And for maximizing or minimizing, just use either first derivative test or second derivative test. Okay, for that just find first derivative, put equals to 0 and find the value of unknowns, and for each unknowns just test second derivative whether negative or positive, and if second derivative is difficult, then you can use first derivative test. So use this well-known technique, just you know also from your previous class. So just do it, these questions for your practice. Okay, and note down in your copy. So 6-7 questions are there. This is for your practice, and do all these questions by taking reference from different types of books. Okay, so these are important because one of the questions may be asked in your exam. So do all these questions in your copy.